Problem number 25. A gas within a closed chamber undergoes the cycle shown in the PV diagram of the given figure. The horizontal scale is set by V of S, which is equal to 8 cubic meter. Calculate the net energy added to the system as heat during one complete cycle. So in this question, we are going to find the net energy added to the system as heat during one complete cycle. So let's we see this green color cycle. So that means it's a cyclic process. But the direction of the cyclic process is in the direction of counterclockwise. So the cyclic process clockwise means the work done will be positive. The cyclic process in the counterclockwise direction, the work done will be negative. So you should be very, very careful. And also in cyclic process, what we studied from the chapter, the theory, which we studied in chapter number 18, your internal energy of the system, which is equal to 0. That means for cyclic process, what is the condition? Your internal energy of the system should be equal to 0. And also if the cyclic is clockwise, your work done will take the positive value. If the cyclic process in the counterclockwise, your work done will take negative value. And also in cyclic process, your internal energy of the system should be equal to 0. And they clearly mention this information in the PV diagram. So where pressure is taken in y-axis, where volume is taken in x-axis, and also its respective values given. So they mention the maximum value in the volume region is V of S, which is equal to 8 cubic meter. So that means if this is 8, so let's we see the value here is each boxes takes the value of 2. So 2, 4, 6, this one is 8. And in pressure, the value already mentioned, start from 0, 10, 20, 30, 40 Pascal they mentioned. So by using this value, we can easily find the answer. So for that, we have to consider for finding the net energy, first of all, let's we consider the first law of thermodynamics. First law of thermodynamics. What we studied in first law of thermodynamics? It's very easy. Q, heat energy, which is equal to change in internal energy plus work done. So if it is a cyclic process, because they clearly mentions a cyclic, so the internal energy will be 0. So this term will be gone. So Q, which is equal to work. So that's the reason for finding the net energy. Once you find the work done, that will be equal to the energy. And for finding the work done, we can easily find the area of the structure, right? So here, what is the area? So here, the area of this green color looks like area of the triangle. So by using the formula for area of the triangle, we can easily find the answer for the net energy added to the system as heat. So here, what I'm going to do, I'm going to write Q, which is equal to W, which is equal to the area of triangle. And also it's the direction of the process is in counterclockwise, so we have to put negative. So what I have to do, negative of area of the triangle is half base multiplied by height. So minus I can just leave as it is. So let's we substitute the value of the base and height. So what is the base here? So let's we go back to the diagram. So the base from point C to B, so the point C at 2 and then B here is 8. So 8 minus 2. Clear, the base is 8 minus 2. The base here is 8 cubic meter minus 2 cubic meter, which is nothing but your base. And what is the height? So let's see what is the height here from the diagram. So the height is from 10 to 30. So 30 minus 10 will give the answer for 20 Pascal, right? So 30 Pascal or Newton per meter square, both are correct. So 30 minus 20, we get the answer. So now I can solve. So half multiplied by 8 minus 2 is nothing but 6 cubic meter, and 30 minus 20 is 10. So now we can cancel. So this is in terms of 3. So 3 multiplied by 10. So let's go back to see what's the value. Sorry, 30 minus 10, it's 20, right? So 30 minus 10, it's not 20, it's 30 minus 10. So that means this is 20, right? So you should be very careful. So that means 3 multiplied by 20 is 60. So minus 60 joules is the answer for this question. That's it. Thank you.